In this video, we are going to understand the concept of max flow and min cut. So for that, we are going to have a small example here, and where we call this as your connected graph. We call it as a connected graph. Okay. If all the vertices of that corresponding graph are connected with each other, then we call that graph as a connected graph. Okay, so out of all the vertices which are there in the connected graph, so we need to identify the source first. We need to identify the source, and also we are going to identify your destination also. So now the first task is that how we are going to identify a vertex which can be called as your source. A vertex which is not going to have any integrity, then we call that particular vertex as your source. Means that suppose if I assume that this is your vertex, so this vertex should not have any edge coming into that particular vertex. Then we call that particular vertex as your source vertex. And a vertex, we need to identify a vertex in this particular graph which doesn't have any out degree. Means out degree means suppose I have a vertex here, and from this vertex, if an edge goes out, then we call it as your out degree. So we need to identify a source as well as the destination for implementing the concept of your max flow and min cut. Now, we understood that this is called as your source in this diagram, and this I call it as your destination in this connected graph. Okay, so now our task is to find the maximum flow. Now, the first task is to find the maximum flow. So now we assume that we need to pass from here to here. We may pass the data, okay, and we may pass a fluid from the source to the destination. And every edge which is connecting each and every vertex is having a value. That value indicates the capacity of this edge. Capacity of this edge means that this edge can carry only 5 units of fluid from this vertex to this vertex. If I say here 10, means that this edge is having the capacity to transfer only 10 units of fluid from 5th vertex to your 7th vertex. Okay, so now what we need to do is we need to find the maximum flow. Maximum flow from the source to your destination by using the flawed algorithm. So now we are going to implement that algorithm, and we'll see what is your maximum flow from your source to your destination. Meanwhile, just I erase all the content which is there here, so that I can clearly understand the components of it. So just what I do is I'll just erase them all so that so now we all know that it is a connected graph, and also we identified the source, and also we identified the destination also. So now we'll see how we are going to calculate your maximum flow by implementing the algorithm called as your flawed algorithm. Okay, right. Now, so now, as I said, this is your source, and we need to reach this destination, and the capacity should be maximum. Now we'll see what are the paths we have. So the path is that I can go from 1 to 2, I can go from 2 to 5, and I can go from 5 to 7. And I can also go in this way, right? Again, I can also go in this way. So out of all these paths, right? So what I need to find is we need to find the maximum flow from the source to your destination. Now we'll see how we are going to apply your algorithm called as Floyd algorithm. So now, so from 1 to 2 vertex, okay, from here to here, the capacity is equal to 7. It means that 7 units of fluid I can send from one vertex to second vertex. But if I see here, right, I can go in this way, and I can also go in this way also. So which is the maximum now? So here the maximum is equal to 5 here. So I'll choose this path. Okay. So if I send 5 units of data here, it means though we get 7 units of fluid here, we can send only 5 units of fluid from your second vertex to your fifth vertex. Okay. Now from fifth vertex to your seventh vertex, the capacity of this edge is equal to 10. Okay. But now what I say now, out of these paths, so from 1 to 2, 2 to 5, and 5 to 7, now we are going to take the minimum value of it. So the minimum value of these three edges is 5. So we are going to assume that 5 minus 5 is equal to 0 here. Means that we are going to send the fluid in this path and the capacity will be equal to 1. So if I send from 1 to 2, 2 to 5, and 5 to 7, so the maximum capacity which I can send through this path is equal to 5. So now this is 0 here because after utilizing all 5 units, we don't have any space to send. And here 10 minus 5 will be equal to 5. Okay. And here 7 minus 5 will be equal to 2. Now, when I find an edge with a value 0, then what I need to do is I need to block this path. Means that no fluid can be transmitted from 2 to 5 because the capacity of this edge is equal to 0. Because the capacity is equal to 0, I cannot send any sort of fluid from the second vertex to your fifth vertex. Now it is done. Now we are going to choose another way now. Now I can even send the fluid in this direction also. So I can even send the fluid in this direction also. So if I send the fluid in this direction, what I need to do is I need to take the minimum of this path. So your path is 1, 3, 6, as well as 7. So what is the minimum value I have in this path? The minimum value I have in this path is equal to 4. So 4 minus 4 is 0. 7 minus 7 minus 4 is equal to 3, and 10 minus 4 is equal to 6. So right. So now whenever, as I said, if the capacity of my edge is equal to 0, what we are going to do is just we are going to block this process. It means that if I'm saying blocking means that there is no edge in between, or there is no capacities to send from your sixth vertex to your seventh vertex. So we are going to close this vertex now. Now we need to choose the another ways now. So the another way I can choose is I can go from here, I can go here, and I can go here, and I can go to this place also. It means that I can even send the fluid in this direction also. So I have a line also here, and the capacity of that line is, if I go to keep that in there, and the capacity of that line is 1. So the capacity of this line is equal to 1. Okay. Okay. So now what I do now, I can even go in this direction from 1 to 3. And from 1 to 3, I can go to 3 to, what do you say, 2 to 3 to 4 I can go, right? And from here to here I can go, and I can go in this way also. So the path will be like 1 to 3, and 3 to 4, 4 to 5, and 5 to 7. And what is the minimum of all these edges which are going to be sent in this direction? The minimum will be equal to 2. Okay, so the minimum will be equal to 2. So what I do is I just subtract my 2 here. So this is going to become 0. This is going to become 1. This is going to become 4. And whenever I say 0, okay, this is blocked. This is blocked. Now, is there any other way to send the fluid from the source to your destination? Just we need to check. So I can't go in this direction, and I can also go in this direction, because if I go here, I cannot have a path in between because it is 0. If it is 0, as I said, it is blocked. So the only way we have is From first vertex, I can go to my second vertex. From the second vertex, I can go to my fourth vertex. From the fourth vertex, I can go to my fifth vertex. And from the fifth vertex, I can go to my seventh vertex. So if I go in that way, so if I go in that direction, so the path will be 1 to 2, then 2 to 4, then 4 to 5, and then 5 to 7. So what is the minimum value I have here now? This is 2, this is 3, this is 1. So this is 1 here. So this is 1. So we are going to keep a value 0. So this is going to become 3. This is going to become 2. And this is going to become 1. So whenever I say here it is 0, then we are going to block it. So the minimum will be equal to 1. So if I sum these values, right? So it is 5 plus 4 is equal to 9, 9, 11, and plus 1 is equal to 12. So the max flow, which I can send from the source to your destination, according to your algorithm, the value is equal to 12. Okay. So now we are going to assume that your max flow value is equal to 12. So whenever I calculate your min cut value, your min cut value should be equal to your max flow. So unless your min cut and max flow are equal, we cannot say these values are the exact values for your problem. So now we'll see how we are going to calculate the min cut for the same connected graph. Okay. Now we'll go ahead. Now we'll take the same, diagram, and then we'll understand how we are going to calculate your min cut value. So as I said here, we are going to have the vertex 1. Then we are going to have my 2, 3. Then we are going to have my 4, then 5, then 6, or 7. So we have an edge here, we have an edge here, then we are going to have an edge here, we have an edge here, we have an edge here, we have an edge here. Okay. And we have a line there, we have an edge, then we have an edge, and also we are going to have an edge here. So the capacity here is 7, this is 10, this is 1, this is 5, this is 3, this is 3, this is 10, this is 2, this is 4, this is 2, this is 7, and this is also equal to 2. So now we are having a graph now. Now what we are going to do is now we are going to calculate the min cut of this connected graph. As we all know that it is a connected graph again. So just I want to repeat the same sentence here. If all the vertices are connected with each other, then we call it as a connected graph. And now we are able to identify the source, and also we identified the destination, and also we are able to calculate the max flow of that particular value, max flow of the connected graph. Now what my intention is that now we are going to calculate, what I say is we are going to calculate your min cut. So for calculating the min cut, what we do is, what we are going to do is now we are going to do a small arithmetic here. So we are going to take x bar, x, and then we are going to have your x bar, and then we are going to have another value called edge set. So we are going to take all these three values, x, x bar, and edge set. Now we'll see what is x, what is x bar, and also we'll say what is my edge set. So what I do is in your min cut, now we are talking about your min cut. So as I said, it is a connected graph. Now what I need to do is I need to make my connected graph as a disconnected graph. What I say, I need to make your connected graph into a disconnected graph. Disconnected graph means that we are going to divide this graph into two parts. What I should do now? So whenever I want to apply your min-cut algorithm, what I need to do is, what we are supposed to do is, we need to divide your graph into two parts. So now we'll see how we are going to divide it into two parts. So the vertices of the first part will be there in your X, and the vertices of another part of my graph will be there in your X bar. Okay, now you are able to understand what is X and what is X bar. And edge set is going to contain the value of all the edges which are to be taken out to make it a disconnected graph. Okay, so we know what is X. X contains the vertices of one graph. X bar contains the vertices of another set which has been divided, and the edge set is the sum of all the edges which are deleted, so that I can make this graph as your disconnected graph. Okay, now we'll see this example. So what I do is, I'll just cut. I will cut my graph in this way. So if I cut my graph in this way, what happens now? This one will be here. It is only one vertex, which is there in this graph, and the remaining all, like 2, 3, 4, 5, 6, 7. So all these vertices will be there in the another set, right? So now what are the edges we have here? So what I need to do is, we need to take the value of my 7 as well as my 10. It means that if you are going to divide these two edges, okay, if you are going to take out these two edges, this connected graph became disconnected graph. So what I do here now, just I will be saying the value as 7 and your 10. I think now you are able to understand how we are going to partition my graph, how we are going to divide my graph into two parts. Okay, so now I think you are able to understand this point, and now we go ahead and see how we are going to do all those things now. Just I'll take out all those things so that I can save some space for you. Okay, is about the first one. Now we'll take out what I do now. I'll take out now. I'll talk about one more X now. X is I'll take out 1, 2, 3 in one set. It means that I'll have a cut. I will have a cut in this way. So if I have a cut in this way, so the first graph is going to contain 1, 2, 3 vertices, and the second graph is going to contain 4, 5, 6, and 7. So what are the edges we are taking out so that I can divide my connected graph into disconnected graph? I have 5, 3, 2, 7. So what I do, just I will write 5, 3, 2, 7. Okay, so this is for this and this is for this. Now we'll go for another option here now. So what you do is, I'll have a cut here now. I can also have a cut here also. So if I have a cut there, what happens now? What are the elements I have here now? I have the elements like 1, 2, 3, 4 are there in X. And what are there here? 5, 6, 7 are the elements which are there in your X bar. So what are the values I have here of my edges? 5, 3, 2, and 7. Okay, this is my third set. Now we go to my fourth set. So what I do is I will cut. I can also cut my graph in this way also. It means I'll take out only this part. So if I take out that part, so what are the values I have now? 1 and 3 will be in your x, and then I will be having my 2, 4, 5, 6, and 7 are the vertices which are there in the another set. So what are the edges we need to cut there? So the edges which we need to cut are 7, 1, 2, and your 7. So how many partitions I could make now? 1, 2, 3, 4 partitions. Now we go ahead and see what are the other partitions I can do here now. Okay, this is 1, 2, 3, 4. Okay, just I will take out this image and I keep this here. Okay, so that you can understand on the whole page. So now what I can do now? So what I can do is I can even cut my graph in this way also. It means that my x is going to contain 1 and 2 is one set, and another set is 3, 4, 5, 6, and 7. So what is the sum of edge set now I have here? So the sum of edge set I have here is 10, 1, 3, 5. Okay, this is a fifth one. Now another way also I can cut now. What is the another way which I can cut now? So 1, 2, 3, 4, 5. So I can also cut my graph. I can also cut my graph in this way also. I can also cut in this way. So if I cut my graph in this way, what is the value I got here now? 1, 2, 3, 4, 5. And then we are going to have my 6 and 7. So what are the edge sets I have here now? The edge set I have is 10, 2, 2, 7. So edge set is 10, 2, 2, 7. Okay, it is my another one. Now we go to another set now. Okay. So if I cut so what I can do here now, I can even cut in this way. 1, 2, 3, 4, 6. And then the elements are 5 on 7 on this set. So the values will be of my 5, 3, 2, and 4. Okay. And I can also cut as 1, 2, 3, 4, 5, 6 will be in one set, and 7 will be on another set, and the value will be equal to 10 and 4. So these are the different combinations by which I can cut. Okay, these are the different combination by which I can cut your connected graph. Okay, now we'll go ahead and see how exactly your min cut algorithm is going to work in your algorithm. Very interesting thing now. See, when I talk about, right, so I decrease the size of it so that yeah, it will be helpful for you, and you can see on one screen. Okay, now just I'll take my video down here. Okay, okay. Now see, 1, what is the value? What is the edge set I have now? 7. Okay, so this 7, from where it is going? From this to here, right? So the control should be in this direction only. Means this set should map to this set only. Okay, if that is not mapping from x to x bar, then that value is not being considered for your min cut. Okay, now we'll see. 7 is there. 7 goes from x to x bar. So this is valid, right? 10. 10 from 1 to 3. So 1 is here, 3 is here. So it is also valid. So what is the value I'll get here? Now we are going to get a value of 17. Now we'll take this now. I have 5. So where is my 5 here? I have the 5 here now. So from which x to x bar. So this is valid. 3. 3 is 2 to 4. 2 is in this x and your 4 is in the x bar. So it is also valid. Now 2. Where is my 2? 2 is, where is my 2? Where is my 2 here? Yeah, I'm cutting my 1, 2, 3. Yeah, 2 is here. So what it is cutting now? 3 to 4. So 3 is here and 4 is here. So this is also valid. Now we are having 7. 7 is in between 3 and 6. 3 is here and 6 is here. So it means that all the elements are valid. So this is 5, 3, 2, 7. So what is the value of my 5, 3, 2, 7? 5 through 5, 3, 2, 7, the value will be equal to 17. Now you come to the third one. The third one, what I have now in the third one, just I'll have line for the clarity. Okay, 5 is there. So 5, what it is doing now, from where we are going to send 5, 2 to 5. 2 is there here, 5 is there here. Okay, done. Where is my 3 now? Where is my 3? Yes, 3 is here. We are cutting here. Okay, 1, 2, 3, 4. So 3 is here. So 4 is here in this set. 5 is in this set. So my 4 is in this set and 5 is in this set. So it is also valid. Now we have my 2. 2 is in between 4 and 6. 4 is here. 6 is here. Okay, done. 7. Where is my 7? 7 is in this case now. 3 to 6. 3 is here. 6 is here. So this is also a valid set. So what is the value of it now? The value of it is equal to 17. Now come down here. So this is okay, this is okay, this is also okay. Now we'll consider this partition now. 1 and 3. So we are having, so what we are having now? Just we are having your, take another color so that, so we are cutting 1 and 3. So we are cutting 1 and 3. So, okay, 7. So what it is happening now? 7 is from 3 to 6. 3 to 6. So it is in this direction. Okay. All these things are there in this direction. Okay. 3 to 6. So 7 is valid. So from 1. 1 is from 2 to 3. See here now. 2 is there. 3 is here. But 2 is in this set and my 3 is in this set. So now this direction is changing, right? So whenever there is an edge from x bar to x, we are not going to consider that edge. So we are going to avoid that one now. Okay, what we are going to do? We are going to avoid that. Now we'll take this 2. So where we are going to have my 2? 2 is from 3 to 4. 3 and 4. Okay, done. Where is my 7? 7 is from 3 to 6. It is equal to. So 7 and 7, 14. 14 plus 2 is 16. And we are not going to consider this 1. Why? Because this 1 is the value from x bar to x, which is not been accepted. So we are not going to consider this one. So the value will be equal to 16 only. Okay. Now we'll come to here now. Now we'll come to this edge set. So what is the value I'll get here now? So 1 and 2. So we are going to cut in this direction. So if I cut in this direction, what is going to happen now? 10. So where we are going to have 10, where we are having 10, we are having 10 from 1 to 3. Okay, it is valid. Then 1. 1 is 2 to 3. 2 is there, 3 is there. Okay, it is also valid. Where is my 3? 3 is there here, which is passing from 2 to 4. 2 is there here, 4 is there here. Okay. Where is my 5? 2 is there here, 5 is there here. Okay. 2 is there here, 5 is there here. So all elements are valid. So if I add them, what is the value of 10, 11, 16, and 19? So the value is going to become 19. Now, coming on to my 6, 7. Okay, so we are going to have a cut here now, because this 1, 2, 3, 4, 5 is one part, and this is another part. Okay, now we'll take 10. So where is my 10? 10 is between 5 and 7. Okay, 5 is there here, 7 is there here. Done. So where is my 2? 5 and 6. 5 is there here, 6 is there here. Done. 4 is there here, and 6 is there here. 2. Done. 7. 3 is there here, and 6 is there here. So it is also accepted. So what is the value of this one now? 10 plus 11, which is equal to 21. Okay. Now coming on to this one now. So 5, 7. So what I do now? I have a cut here now. I have a cut here. Now we'll see what happens if I have a cut there. So 5. So where is my 5? My 5 is in between 2 and 5. Okay. 2 is there here. 5 is there here. So accepted. Then 3. Where is my 3? 3 is between 4 to 5. So 4 is there here. 5 is there here. Okay. This is also accepted. Now 2. Where is my 2? My 2 is in between. Where is my 2? Yeah. Where is my 2? We are cutting 5, 7. 5, 7. So we are cutting 5. Okay. And, 2. So we have the elements as 5 is been cutting, 2 is been cutting, yeah, 2 is cutting. Okay, so altogether what it is happening now, this 2 is not valued, right? Because these sets are in different, right? So these two sets are different. So we are going to subtract my 2 here now. And 4 is in between 6 and 7. So we are going to have this 4. So altogether, what is the value I have here now? The value I have here is equal to 12. And then the last one, 7. So what are the elements I have here? What are the elements I have here? The elements I have here is 10 and 4. So 10, if I take out all those things, so these two values are valid. So the value is going to become 14. So what I need to do now, I need to take the minimum of all these elements. Okay. So if I take the minimum of all these elements, so what is the minimum value of this one is equal to 12, which is equal to the max flow. As I said in the beginning, whatever the value I get as a max flow should be the value of my mean flow. So unless until your max flow and mean flow are same, you cannot say that this problem is correct. Okay. Yeah. So for clarification, of the earlier hiccup which we got in the video, now just I have drawn things independently so that you can understand it very clearly. Okay. So now what is the set I have here? The set which we are going to devise is 1, 2, 3, 4, 6 and 5, 7. So 1, 2, 3, 4, 6 is a set, and another set is 5, 7. So what I need to do now? 5. So 5 is an edge which is in between 2 to 5. So this is in this direction. So it is satisfied. Now 3. 3 is in between 4 and 5. 4 is in this set and 5 is in this set. So this is also satisfied. Now we need to have 2. So from 2, 5 is in X bar and 6 is in the X. So the connection is in this direction. So whenever you find the connection in this direction, what we are going to do is we are not going to take that one. And then we are having 4. The 4 is in between 6 and 7. So it is valid. So now this one will be equal to 12. So I think this sequence, I think we understood. And now we are able to understand how we are able to calculate your min cut value. Okay. So in this video, I think we understood the concept of how we are able to calculate your min cut, max flow. In the further videos, we are going to have another concepts of your advanced algorithms. Same. Thank you.